Differentiation. We are looking at differentiation from the angle of composite function now. So we want to solve differential problems using composite function derivative method. Now, if we have a function of y equals to u, if y is a function of u and u is also a function of x, then we call that chain function, or we call it function of a function, or composite function. Y is a function of u and u is also a function of x. Now, to get the derivative of y, then we must differentiate y with respect to u, and then differentiate u with respect to x, then multiply the two derivatives. That will definitely give us dy dx. Yeah. For example, example 1, we have y will equal to 2x plus 2 to the power 3. Now, here we know that we say let u equals to 2x plus 2. So this is the general equation, this equation 2. Now if you relate equation 2 and equation 1, we arrive at y equals to u raised to the power 3. Right? That's normal algebra. So we cannot differentiate u with respect to x and y with respect to u. So that means du dx will be 2. Y dy du will be 3u squared. Now, dy dx now is the product of the two derivatives, which is 2. Dy du is 3u squared, then times du dx, which is 2. Let me write out the formula. Dy dx is dy du times du dx, and that is 3u squared times 2, which is what? 6u squared. So from there, we recall that our u is 2x plus 2. So dy dx will now be equal to 6 into 2x plus 2 all squared. So that is the derivative of this function. Now, we can solve it using an alternative method. The alternative method, since our y is equal to 2x plus 3 to the power 3, now dy dx will be equal to, we bring down the power, then we differentiate what we have in the bracket, that is 2, then we repeat the bracket, 2x plus 3, then we shorten the power by 1, so we have 3 times 2, which is 6, into 2x plus 3 to the power 2. So that is the alternative method of differentiating a composite function of this form. Now, example 2. We want to differentiate another function. We have y to be equal to 3x squared plus 4x plus 3 to power 2. Now at this level, we can use the traditional with the conservative method. I say, okay, this is equation 1. I say, okay, let u be equal to 3x squared plus 4x plus 3. That gives us second equation. Now, that automatically gives y as u squared. Yeah, if we relate equation 2 and equation 1, we have that this is u. So y will now be u squared. Now, differentiating u with respect to x, we have 6x plus 4. And differentiating y with respect to u, we have 2u. Remember that dy dx is the product of du dx times dy du. So that is dy du, which is 2u, times du dx, which is 6x plus 4. So we have 2u, but our u is what? 3x squared. 3x squared plus 4x plus 3 then into 6x plus 4. So that is our derivative, the derivative of this function. We just differentiated the two functions individually, then we multiply the derivatives, and that gives us the final answer. Alternatively, Alternatively, if we have the question as y equals 3x squared plus 4x plus 3 all square, the y dx will be that we bring the power down to multiply the derivative of this function. We differentiate this, we're going to have 6x plus 4. Then we repeat the bracket, which is 3x squared plus 4x plus 3. Now shorten the power by 1. So we have 2 into 6x plus 4 into 3x squared plus 4x plus 3 raised to the power 1. So that gives us the same thing as we had earlier. That's the alternative method, a short-cut method for students that will be writing OMR exams. Finally, on this particular subtopic method, let's example, we have y equal to 3 minus 3x to the power minus 2. Now, say we can use our alternative method straight. Then the y dx now will be equal to the power, which is minus 2, multiplying the derivative. The derivative of what we have in the bracket is minus 3. Then repeating the bracket, 3 minus 3x. Then shorten the power by 1, that's minus 2 minus 1. You have to subtract 1 from the power. That means we are differentiating it. And that gives us minus 2 times minus 3, that is 6. Into 3 minus 3x, now to power minus 3. Or we can rewrite this answer as 6 all over 3 minus 3x to power 3. That's all. That is all there is to differentiating composite function using the derivative rule. Thank you very much. I wish you all the best.